Happy Earth Day this year from all of us at the FieldKit team. For Earth Day 2023, rather than do a big event, we thought we'd get a few members of our team together for a nice casual chat, give you an update about what we're doing at FieldKit and some of the things we're looking to do in the future. We don't have our full team here today, but with us, we have Shah, our co-founder and executive, basically our everything guy, let's be real. Got Jacob, our chief software engineer, Pete, our instrumentation scientist, and then Sarah, our product manager. And of course, I'm Lindsay, community manager, here to kind of help steer the show around. I'm just going to go through a couple different things, and we're going to get started with a general state of FieldKit, what we're looking at hardware-wise, and the question that we get from some of you out there, which is when we're going to be looking to start selling FieldKits in our shop again. So that's going to be Shah. Shah, take it away. You're on mute.
Thank you. Hey, everyone. So, I first off, I wanted to say happy Earth Day to all you folks out there. Earth Day is one of my favorite holidays because, it's nice. It gives regular people a moment to step back and think about the planet and our impact on wildlife and ecosystems and all this sort of stuff. The kinds of things that a lot of us think about every single day. It's just a reminder for general public to kind of step back and think about that. And it's a nice thing that we end up doing. I definitely want to kind of give a deep thanks to anybody who's watching this right now and kind of your continued support of FieldKit during this crazy time that we're living in. I'll talk a little bit more about what I mean by the crazy time, but I have the amazing opportunity to talk to a lot of folks in the conservation and the field science world. And I'm continuously inspired and excited to hear about all the projects that you're all working on and the things that you're doing. And it inspires me to think about ways that we can build better tools to help further support the work that you all are doing. Because I think we know that the current availability of tools is not great in terms of cost perspective or an accessibility perspective, or even an ability to modify the things. And that's really what we're trying to focus on with FieldKit, is how that we can build better environmental sensing tools for folks out there. And there's a subset of you that have been helping us to deploy these things and test these things, and that stuff has just been absolutely fundamental while we sit in this position where we haven't really been able to build the numbers of FieldKit that we hope to. The team here and the folks that are not on this presentation are deeply dedicated to growing FieldKit into a scientifically accurate and reliable environmental sensing product line that's accessible to anyone who wants to just have a better understanding about the planet. For those of you that maybe don't have a deep understanding of what FieldKit is, it's a couple different things, right? So we build hardware, and that hardware varies. It's environmental sensing hardware. Here's one of our this is our core board and the module base. And so this is kind of the backbone of a FieldKit. This top piece right here is made up of two different boards that sandwich together, and it's pretty much a data logger, if you've ever heard about data loggers used. So it's got GPS and Wi-Fi and a screen and memory and all this sort of stuff on board that allows it to gather data, collect it, and save it with a GPS stamp. There's an SD card slot on it that allows you to save data to an SD, but it also has a flash memory on board that allows you to save the data to there. So every FieldKit is essentially making two copies of the data. We have this module base that plugs into the bottom of it, and that allows you to connect up to 4 different FieldKit modules. So here's an example of a FieldKit module. Jacob's also holding one right now. This is a water temperature module that we have created. We have done water temperature, pH, conductivity, dissolved oxygen. We have ORP, we have a weather station, we have a water level sensor that we've created. And then there's a bunch of kind of prototypes of additional sensors that we would like to create in the future. And we're working on right now things like air quality, soil moisture, turbidity, all sorts of different sort of sensing things. There's something out there that you're really super passionate about, and there's not a good tool that can be purchased to do that, then please reach out to us and let us know, because we can definitely put it in the pipeline of things that we're trying to develop. So one thing about this hardware, 100% open source. So all the designs, all the code, the software that's running on these devices, the calibration procedures that we go through for them, things, every single piece of FieldKit is meant to be entirely open source, which means that every single person listening to this talk right now can go out and build their own version of FieldKit if they would like to do that. FieldKit is a non-profit, even though we manufacture and sell hardware, plan to sell hardware, we're a non-profit. So our mission is tied to making sensing things easier. It's not tied to selling a bunch of devices. It's not tied to becoming super profitable. It's tied directly to how do we kind of, change the paradigms around environmental sensing so that people aren't having to spend a lot of money to get these very expensive, convoluted, and hard to use systems to be able to do this sort of stuff. So, so we actually encourage that people try and build their own field kits if they can. And the team here is very dedicated to helping people do that. So if you are interested in doing that, please reach out. We'd be very interested in trying to help you do that. And Lindsay, our community manager, is the perfect person to reach out to with that. So, the team is very dedicated into growing FieldKit beyond where it is right now into something that is accurate and reliable and useful to everybody who's listening here today. We deeply believe that the current state of scientific tools is just not good enough for what we need to do, especially as we see, impacts to climate change, impacts to species extinctions, and all sorts of different things as we're going on. And we have plans over the next couple of years to focus very deep on that whole thing. There's a lot of really exciting things that we're developing, and that we're continuing to test these things in the real world to ensure that they'll work for the folks out there as they're trying to do that. So, in the beginning, I kind of alluded to a crazy time. That's really around the fact that the pandemic was pretty much the worst time in modern history to build a product, build a hardware product, and that we struggled a lot on that. And I'll get into a little bit more detail on that. It seems like we're coming out of that struggle, which is quite nice. But during this time, we haven't just sort of been sitting around. There's been a ton of work on kind of smaller deployments so we can make sure that we test a lot of the bugs in FieldKit. We've continued to sort of develop the portal and the app and the different sort of pieces of it. The other parts of FieldKit that I didn't mention earlier are these portals, the portal and the app. So if you go to fieldkit.org, there's a data visualization portal that we have built. And that allows you to kind of, once you download data off your sensors, it allows you to explore and visualize that data, to make comments on weird things that you see and share it on social media or with colleagues. We've built this portal in a way that, as you change around the data view, it all gives it a unique URL, and that URL can be used in references to things, or it can be used to share so other people can see exactly what you're looking at when they're looking at that. And we have a lot of ideas around how that portal can be used by even people who don't even have FieldKit hardware to help to understand water quality in regions or weather throughout an area, and kind of share it and comment on it and really engage with the data in kind of a more dynamic way. The last piece of FieldKit that I didn't mention before is the app. So we have an app for both Android and iOS, and it's meant to be the main interface to the hardware for most people. So, we're all so used to using apps to connect to things like GoPros or, our toaster at home and things like that. And so we've kind of taken that same mechanism and built into a way that the app can actually connect to the Wi-Fi that the device creates. And that allows you to download data off it, change settings. You can do a lot of different stuff when it comes to that as well. And this is another piece that we're continuously working on to try and evolve. So I want to talk kind of honestly a little bit about the supply chain and the things that have impacted us. Originally, the plan with FieldKit, and it's kind of why we decided to do the FieldKit 50 giveaway in 2020, was that 2020 was the 50th anniversary of Earth Day. It was a really exciting time, and that we wanted to officially launch FieldKit on that day. And that meant making a bunch of field kits that were available for people to purchase. We set up pre-orders on the website and did all this sort of stuff. Well, April 2020, the 50th anniversary of Earth Day happened right after the pandemic hit the world, right? And that had huge implications. Everybody was very scared around that time, so we decided that we didn't necessarily want to launch a product in the middle of a global pandemic. And so we stepped back. We said, okay, we'll build some field kits. We'll give them away to some really interesting people doing cool work. And then we'll just manufacture things as we go. Well, the manufacturing and the whole supply chain, since a lot of that stuff is based in China, where the pandemic originated, had huge effects. I mean, factories closed down, companies went out of business. Access to clean water meant that certain chip manufacturers were not able to do that. We actually wrote an article about it on the FieldKit website if you want to read in much more detail about the sort of things that we ran into. But part of the biggest issue around it was that you had these companies that were going to stop manufacturing things for a while until they can get people back in the thing. And then you had a bunch of big, very rich corporations like Apple and Microsoft and all these other companies go through and just buy out a lot of the hardware. So smaller folks like the FieldKit team got left into the situation where the lead times on some of the things that we wanted to purchase was very long. I mean, some of the lead times, we still haven't gotten parts that we ordered during that time. So it's been 3-4 years to try and get things out of it. Not only that, but it meant that, we were in this state where we had to maybe redesign some hardware to try and get around the issues that we were facing. And so we focused on some of that, and kind of did a lot of work. So what are we doing to sort of fix the supply chain issue? There's a number of different things. One thing I will say is that our hardware engineer, our main electrical engineer, Bradley, is really brilliant when it comes to this sort of stuff and thinks a lot about supply chains and folks in that space. He talks to a lot of people and gets a good idea of where things are going. So we've actually done a good job, I think, of purchasing for the future. And I think we're in a good position. We are always constantly revisiting these purchasing decisions to make sure that we get in a place where we can have a steady output of field kits coming out and weather any sort of storms that we might see in the future. Another thing that we're doing is we're moving manufacturing out of house. So, up to this point, the majority of things for FieldKit, we've all been built by Bradley and on manufacturing equipment that our team has purchased and have in our labs. So, that is a great thing for us to really understand the hardware and do things, but it takes away from further sort of development and bug chasing and all sorts of stuff that our engineering team could do, because they're also the ones doing manufacturing. So we have a fantastic small batch manufacturer that we've been working with that's going to take over and has already started taking over some of the manufacturing of equipment that we have into the future. We're hiring new engineers, both software and hardware. So if you're interested in working with FieldKit, we would absolutely love to talk to you, and that will kind of allow our engineering team to have a little bit more leeway to develop new products and do other sorts of things that we would really like to do. And the design of all the hardware we have moving forward kind of has this deep focus, thanks again to Bradley, around how do we think a lot about part selection. What do we think about the inventory that we already have, the things we're already using on other pieces of FieldKit, and how do we design future pieces of FieldKit in a way that is kind of much more pandemic proof than I think the previous sort of stuff was. And that runs across like our inventory and our product lines. So, you know, there's a lot of thought that's been going into a lot of this sort of stuff. Fortunately, we're in the place right now where we're going to be able to build a bunch of field kits. You know, our goal for this year is to build you know, as much of as 1,000 different field kits. So, you know, we're in the process of building hundreds right now. Those are meant to be available to folks who want to use them on projects, available in the store. We have a bunch of internal field kit projects that we're working on in places like the Amazon and Cameroon that we're continuing to supply hardware to as well. And then also one of the things that we would like to do this year, kind of one of our commitments is a greater focus on indigenous scientists and folks that are doing science in those in places, you know, in the global south and the tropics and regions like that. And how do we, you know, provide tools to those people? So please, you know, keep a watch over us. We're going to be announcing a lot of really exciting things in that space over the course of the year. But right now we're really just focusing on making sure that we can kind of have enough units to be able to do that sort of work, and also work through all the sort of the model around manufacturing and inventory and all that stuff to make sure that we don't fall into the same sort of issue that we ran into today. You know, we really feel and we stand firm in this belief that we think FieldKit is unique and viable. This business model we're thinking about, where, you know, we can be a nonprofit that is also grant but also revenue funded, and we can create open source environmental technology that's well designed and accessible, and it helps a lot of folks who are out there. So, you know, this is something that's exciting, and I think we can prove it out now that we're emerging from the chaos that was COVID-19. So there's a couple of things that we're working on internally that I just wanted to mention, things that I think that are really important. One thing on the that you can also see on our blog that we've talked about before is we've created these new water modules. And these water modules are focused around kind of being completely open source. When we initially launched FieldKit, we were using a piece of hardware from another company, a closed proprietary for-profit company that we weren't entirely happy with. And so we've created these new versions. This was a huge development effort, and it was something that we poured a lot of testing and design changes and all sorts of stuff into. But it's really exciting because it means that, you know, if you're interested in measuring things like pH and conductivity and temperature and things like that, that you don't necessarily have to go to this one specific proprietary companies, that, you know, these things can be spun up on your own using parts that are very easily available from a lot of folks. This has made it onto a new product line that I'll talk about in a little bit that I think is quite exciting. We're also thinking a lot about FieldKit applications in other sorts of areas. So, you know, there's work happening on how do we think about extended batteries. So, you know, like in a situation where a FieldKit doesn't necessarily have great view of the sun, where solar isn't an option, how can you create something that allows you to kind of run a FieldKit for much longer? And Bradley's hard at work at some very interesting designs that I think could be quite innovative across the industry on how we can deal with battery and power charging options. And that also applies to applications that are in very cold environments or other sorts of places where lithium-ion batteries don't really work as well. And, you know, one of the things that this sort of situation around manufacturing has put us in is it's given us the opportunity to think very deeply about this FieldKit design and what we would want a FieldKit 2.0 to look like. So we're right now in the kind of early stages of that, of thinking about FieldKit 2.0 and any sort of improvements or changes that we would like to make to that. So it's actually, you know, I'll put out a call if anybody out there has, you know, strong opinions about things that should be included or shouldn't be included, and why. We are always happy to hear and talk about it. The team here will get on a call with anyone at any point. So please feel free to reach out. We're always interested in that as well. I will also say that there's a couple of things that Lindsay is going to talk about later on in this talk around you know, a big strong dedication we have this year to documentation, to community building and things like that. And then also we've done some work with other organizations like the City of New York that have brought on new portal features that we'll talk about in greater detail.
Current work and our future work is being shaped by the interactions and the feedback that we get from the folks that we're working with. I'm constantly talking to users, potential partners about what their needs are. And particularly, like, you know, as with any technological product, we're running into things that it's like, wow, no matter how awesome we thought this was, it is not working for people. And so we're going in and redesigning it. So I, you know, as somebody who's interacting with people in that way, I always want to hear, like, what's not working? What do you really want to see different? Those are the things that allow us to build this better version of the FieldKit that will help serve more people.
One of our partners over the last couple of years was the Wildlife Conservation Society and Florida International University. And this was around a project that was happening in the Amazon basin that was called the Citizen Science for the Amazon Project. That project was focused around understanding how the water was changing, how the fisheries were changing. And we had been deploying a number of field kits throughout that region to kind of get a better sense of things. So when I talk about field kits previously, those are basically terrestrial field kits. What it means is you have a box, a field kit box that we've designed that the device itself sits inside of with some batteries. You plug in solar panels, you put that stuff out into the world, and it measures, you know, whatever it is that you're trying to measure based off of that module. We, for a number of years, had been talking with folks who were very interested in using the same sort of model, but in an area where environmental sensing is much, much more expensive. And that is in underwater, marine, you know, and freshwater applications. So, you know, if you don't know a lot about what is available in that space, if you want to measure conductivity or temperature or pH and these sorts of parameters in a marine application, these sensors are incredibly expensive. So we started a project that kicked off in the middle of the pandemic with Smithsonian Tropical Research Institute around how do you take everything we've learned about this terrestrial application of FieldKit and how do we make it into a package that would work for kind of marine underwater applications. So we went through and kind of we designed this very complicated and large sensor package that would include kind of the, you know, the things necessary for underwater applications, the ability to add marker lights, and stuff like that, and then also leverage a lot of the improvements that we've made with a terrestrial field kit into a package that works to go underwater. And so this is what the field kit underwater actually looks like. This is an unpopulated board, but the board itself has integrated circuitry that will measure things like pH and conductivity and water temperature and pressure and all the sorts of like basic measurements that you would look for in this sort of hardware. But it also, in kind of the interest of creating another sort of flexible and adaptable sensor configuration, it also has 3 bays for these modules on it as well. So you can add additional sensor modules to this device that isn't currently on board. That's interesting because it allows you to maybe add a new type of sensor that you developed, or put something like turbidity on there, or say you want to have 4 pH sensors on this single device. You could do that just by plugging and playing, and it just works immediately off the bat. The other interesting thing that we're doing with this is we're thinking a lot about power. So, when you put something underwater, you don't have access to solar power necessarily. I mean, you could connect these to a buoy, but we're thinking a lot about how do we come up with a very clever power approach. And Bradley has created a battery sled that fits in on the back of this, and he's currently working on another version of that I think has some really innovative and interesting ways about how it deals with charging and power, and allows you to deploy these things underwater for considerable amounts of time. And so that's something that we're currently investigating and looking through. We sent the first prototypes of this to STRI to deploy locally. And our plan is to build another 25 of them that will be given to STRI in Panama to deploy around the region. But we are planning on building, another maybe 25 to 40 of these things that will then go off and be used by organizations that we've been talking to, like Hopkins Marine Station, Mbari in Monterey, and a bunch of different other people who are interested. So if you are interested in testing out one of these things and exploring what an underwater field kit would look like, please reach out, because we're in a position where we are going to be giving these to people that we think are doing interesting work, and hoping to work very closely alongside them to make sure that this answers the questions that they're looking to answer there. So, the current version has a 100-meter depth rating, and we've been looking at a 300-400-meter depth rating. We also have hardware that can go much deeper, like enclosures and things like that. So if there is kind of crazy ideas or interesting things that people are thinking about, please reach out to us and let us know, because it's I think it's a very exciting thing, and we'd be happy to partner with folks about whatever it may be. Pete, do you want to maybe add anything else that you might have about FieldKit Underwater and kind of the potential of this product?
Sure. So FieldKit Underwater is really supposed to be in the same area of applications as sondes from various other companies. And so the idea is to have a sonde, which is to say a device that can actually take measurements from multiple different sensors at the same time in water, and then add to it the data logging capability that some sondes still lack. The other thing is that by having multiple different sensors co-located with one another, in this case, pH, temperature, I was going to say barometric, but really water column pressure, dissolved oxygen, and electrical conductivity, we get an idea of not only what depth the sonde is sitting at, but also what the chemical environment is at that particular depth. These are things that oceanographers always refer to when they're trying to take their measurements, but also limnologists and anyone doing any sort of riverine ecology, biogeochemists, hydrologists, all folks who would be interested in this particular sort of equipment. In our development cycle, what's been really amazing to me to watch is how we've arrived at a number of different improvements on our basic design that are also familiar to me from my background in doing work in a marine setting. Having worked with marine acoustic recorders in the past, I definitely pointed out, yeah, we're probably going to need marker lights. And Bradley also had the idea ahead of time, which is how we wound up with a electrical engineer nearly blinding himself with a large number of very bright LEDs. The stories we could tell about the development work that we've done, including the bathtub tests that I've done on the enclosure, and the one time that I had to deliberately explode the enclosure, or rather explode one end out of it so that we'd know what would happen if our lithium batteries caught fire are myriad. We have a lot of things that we do to make certain that what you get is safe, but also that what you get will function. So yeah, this is superb to be operating on something that is going to be taking the state of the art and trying to depress the price point while retaining the same level of accuracy for research grade data output that we're trying to hit. One other thing that I'd point out is that I would like to also give a shout out to a friend of mine, my colleague Rolf Hutt at TU Delft in the Netherlands, who encouraged us to not use the name FieldKit Marine because of the fact that, well, this isn't just for marine work. This is for lakes, this is for rivers, this is for streams. If you do freshwater work, FieldKit Underwater is also for you. So thank you, Rolf, for reminding us that it's not just oceanographers out there.
Also, this has been kind of a fun project for the whole FieldKit ecosystem too, because a lot of the things that Shah was talking about with regard to FieldKit 2.0 have sort of snuck their way into FieldKit Underwater. And so that's also been fun from a development perspective to see, sort of a peek at what we're going to be able to do on the next iteration of the terrestrial hardware. And so, yeah, it's exciting for lots of reasons, I think.
Thank you, Shah. Thank you, Pete. Thank you, Jacob. And I know I'm super excited to see what the future holds for FieldKit Underwater. And speaking of specific gratitude for dunking things in a bathtub and trying to blow them up, Pete, love to hear a little bit more about kind of what the landscape, as you've heard, like we do really robust testing. We're trying to put everything through its paces before we get it out to people, which has been part of some of our delays. So Pete, love to hear more about the work you've been doing around testing, around building up our calibration protocols, and this sort of whole landscape of all of that.
All right, Lindsay, to answer your question, there's a lot to testing. From last year, actually, let's start with that. You may recall from last year's Earth Day after school special, we put a field kit on my property in Forestburg, New York. That field kit is not currently there because of the fact that first a tree was dropped on it, but that did not kill it. No, what actually killed the field kit unit was a bear using it as a scratching post for its back. This is the sort of testing that we kind of have to do. I've actually given lectures before and talks about some of the hazards of environmental sensing systems, and one of my lines used to be, don't trust cows because they will use your cables for floss. That remains true. But also apparently bears like using fence posts as scratching places. So that's not the least of the testing though. Insofar as our calibration and testing protocols go, there's been a lot of work that I've been doing, especially with Sadie, who runs a lot of our QA work, and Anthony, who's been doing a lot of the calibration work in-house in our lab in Los Angeles, designing the calibration protocols so that you can get traceably calibrated outputs from your field kit. Now, let me back up a step because I like throwing around terms like traceable calibration, and a lot of people don't know what they mean. Traceable just means that the calibration that we do, which is to say, making certain the values that come out of your unit happen to be in line with values that are real in the real world. Traceability is taking calibration, but taking it from a standard, something you're calibrating to, that has been measured against another standard that is known to be trustworthy at a higher level. That is to say, something even more accurate or even more precise. And in this case, those standards work their way up traceably to, in the US, the National Institute of Standards and Technology. So NIST has their primary standards, and then trickling down through multiple layers, we get to the standards that we use. What's nice about that is then you can compare your data with anybody else's research data that's also from traceably calibrated instruments, and you don't have to worry about whether or not those measurements are compatible with each other. 1 milligram per liter or 1 microsiemen per centimeter on one unit will equal 1 microsiemen per centimeter for conductivity, for example, on another unit. 1% oxygen for dissolved oxygen will equal 1% dissolved oxygen on another unit. So that's part of what we're trying to make certain that you have accessible to you through the calibration that we do in-house. Insofar as the testing, that's really more a matter of making certain that everything works the way that we hope it would. And in particular, a lot of the work that we've been doing is making certain that all of our water quality modalities will work with one another when submerged in the same body of water, connected to the same field kit. There have definitely been challenges around that insofar as the electronics go, and developing large bodies of test protocols has been one of the most challenging things in my year this past year, so that we can make certain that across multiple people within the FieldKit organization, we can have a lot of duplication of the same tests at the same time so that we can get data back that will allow us to guide our development in a reliable direction.
It's great, Pete. Really appreciate it. It's I think sometimes you have simultaneously the most stressful and the funnest job of breaking the hardware, figuring out how to not break the hardware, telling other people how to break and not break the hardware, and making all of that into something that is extremely useful, as well as doing calibration 101 courses for every single member of staff. So
I will say, having a bear take down your station, though, that's probably the most unexpected testing scenario I've probably run into so far.
Yeah, well, I appreciate you bringing that up, because that's been a part of a project I've been working on with respect to documentation. We have on our website this very extensive product guide that goes through, in exhaustive detail, how you put together a field kit, how you make sure that all of your sensor modules are going to be working flawlessly together. But one thing that we don't necessarily have as much of is that kind of real world documentation of, like, how do you install this to get the best possible experience? How do you prevent a bear from using this as a scratching post? Obviously, we can't necessarily imagine every instance that's going to happen, but one of my big projects has been sort of finding out from people, where are the sticking points that we didn't think about in terms of documentation, and putting more of that both in writing, and then also we're looking to put together videos around different things, videos about, say, the best way to install a field kit weather station so that you're getting the best, most accurate data out of it. How to install a water level sensor, because that does often require a little bit of architecture with the Unistrat. All these things are stuff that I'm really interested in getting out there so that we can really be as useful as possible to people, because as a team at FieldKit, we know we're working with a lot of folks who've been doing this kind of ecological and field work for a while, but we're also working with people who maybe have never done it before and who are just wondering about how to keep your probe cables from turning into, like, useless spaghetti. So that's been a big part of my project around documentation. In addition to that, and one of my most exciting projects that I've been working on is we want FieldKit to be for not just for people who are native English speakers. We want FieldKit to be for everyone, and part of that is developing a multilingual framework, not just in our documentation, but really throughout the entirety of the FieldKit experience. And so I have been building out with Jacob and our development team frameworks to be able to experience the app in Latin American Spanish, to be able to experience the portal in Latin American Spanish, to be able to peruse our website in Latin American Spanish. And eventually we're looking to spread that also to Portuguese, to French, and then on to other languages. So very soon we hope to start to be able to have some of this visible on the site, and we're running the translations through Crowdin, which is a crowdsourcing platform, so that if you go in there and you say, wow, Lindsay, you translated this wrong with your college Spanish degree, you can go in and catch that based on your experience with a particular technical component or things along those lines. So this is just part of our sort of our community efforts for the next year and coming years is building out this experience to be something that's useful for people. And certainly in talking with some of our partners who are Latin American based, being able to use the app in Spanish, I think will really make a big difference in terms of how folks are able to access the hardware and solve their problems with it. In terms of projects we've been working on, I also wanted to share. Shah alluded to this. We worked on a really cool project with the city of New York, NYU, and CUNY. We talked about this in some previous things, and this is the Floodnet project. So I'm actually going to share the dashboard for Floodnet. So we built out a data dashboard utilizing the FieldKit portal and the Floodnet sensors to create a real-time map of flood data in the city of New York. So here you can see, zoom in and see where particular sensors are located and whether or not flooding is occurring in a certain area. And as part of doing this, we worked with members of the community, with scientists working on this project, with civic leaders in the area, all sorts of different folks to try to figure out what their needs are with a tool like this and how we can build something that provides as much value to a flooding researcher in New York as somebody who just lives in an area and is concerned about flooding. So here you can see developed a lot of new functionality in the portal, the ability to see this kind of real-time stuff in these bubbles, to go in, see the graph right here showing you what real-time flooding looks like, and then go into a particular sensor and see what is happening, for example, in this area in Brooklyn. And see here, zoom in, you can make comparisons with other sensors in the area on the same chart. All of these were developments that we've added to our portal based on our work with Floodnet and needs. And we're just so immensely grateful to have had this project that gave us access to this really great group of people and their needs that we then brought back to our own portal and are using to make it even more awesome. So anyone has access to this at dataviz.floodnet.nyc. We have a blog post about it at fieldkit.org. And I encourage you to check it out because it's a really cool project, and they're adding a whole bunch more sensors, and it's really fun to go in there and interact with the data and get a sense for what is happening there.
Yeah, I just kind of a little bit to add on to Floodnet before we move off of it too, is the exciting thing about it is we've really thought of FieldKit in two new ways. One is, how do we make FieldKit, the portal, the website, useful to people who aren't using FieldKit sensors? And that's something that we have thought deeply about and developed through this Floodnet project. So if you're out there, you want to use FieldKit, maybe you have some existing sensors that are not FieldKit sensors, and you can potentially be able to kind of combine them with FieldKit sensors, use the portal without using FieldKit sensors. All these other opportunities come out of this sort of space as we're thinking through it. The other really exciting thing is, Floodnet wanted to use the FieldKit portal, but they also wanted to have it on their website and under their branding. And so, this is kind of a way of, how do you take FieldKit, like the infrastructure that we've built and the software we've built, and how can you kind of white label it for use by other organizations so that, under the scenes, FieldKit's running everything, and we've kind of created the data visualizations and the codes and stuff like that. But if you want to be able to put it on your own homepage, if you want to have your own logos and stuff, we're thinking a lot about, like, what does this Floodnet experience mean for us to give other people the ability to kind of create their own white labeled version of FieldKit as well, which is really cool and exciting. And it gives a lot of people opportunities to kind of add this functionality to their own places.
Yeah, those are both I think, really key parts of the project. And since the lion's share of that cool Floodnet work was done by Jacob, do you have anything else you want to share on the Floodnet project, Jacob?
Yes. One of the nice things about that project was being able to focus really intently on a part of the ecosystem, the FieldKit ecosystem, and really deliberately on the portal, because there's a lot of work that we have to do, and sometimes we don't get to really zero in for several months at a time. And so I think we can also we saw how we reaped the benefits of that, and so I'm hoping we'll be able to get more chances to do that on the other areas coming soon.
Yeah, one of the in all of the user interviews I did as part of that project, it was really interesting to see the things that we hadn't anticipated as being an issue, like the interactions with the data scrubber that felt so intuitive and natural to us. I found, talking to a lot of people, they just didn't really quite figure out how to select the data intuitively. So we went in and we designed and added some handles and stuff so that it's much more intuitive. Those are the sorts of things that, like, you just can't get sitting in a room and designing software, like, in a group of people that are in it day in and day out. So it's I always love these opportunities to work with different groups, disparate groups, to be able to get those perspectives and incorporate that into the hardware, the software, and everything that we do. And speaking of cool projects, Shah and Jacob, y'all just got back from quite the experience in Cameroon that I think would be really fun to cap things off with, sharing our project out there and the work you did going into it.
Yeah, I'll start and then maybe kick it over to Jacob. So the two of us actually spent the month of March in this incredible protected area, UNESCO World Heritage Site in the southern part of Cameroon called the Faunal Reserve. It's actually this picture that you see behind me here. This is the research station that we stayed at for a month. The work there is something that we had started with UCLA and this organization that's based in Cameroon called the Congo Basin Institute, who's really focused at creating infrastructure that allows people access to understand these ecosystems and monitor wildlife and perform field science and do all these sorts of things there. And so it's a project that we had been working on for a number of years. We had planned to go back and do more work on it, and in early 2020, and again, the pandemic stopped things. And it wasn't until this last expedition in March that we were really able to go and fully implement it. So what we have built in that area is a radio network that allows anybody, it's an open radio network that allows anybody to bring back data real time that's being collected in that ecosystem. The Faunal Reserve has a very interesting geological format in that you have these giant rocky hills, the Inselbergs or rochers that jut out of the environment. They're well above the canopy, and they provide this very interesting opportunity to create essentially radio towers in the rainforest that can collect data and bring them back to camp. So we've set up a bunch of these nodes throughout 4 of these hills in a 25-kilometer region, and that data gets brought back real time to this camp that you see, actually to this building right here, and uploaded via satellite internet. We also have a series of FieldKit sensors. You can see them behind me here. These are couple weather stations that we've deployed in the region, and we're continuing to develop the project and think about things like GPS tags for animals and other FieldKit sensors and all sorts of stuff that can be used out there. Jacob, why don't you talk a little bit about our time there so we can you can tell them about the things we saw.
It's pretty wild to look back on it. It's hard to believe that it was a month. It seemed to go by really quick. I think it was one of those trips where I think we got to Yaoundé in Cameroon, and we were really excited to get into the field and just get started. And there was a couple days of gathering up stuff, and we finally got out there. Really long hike to get out there, and I still remember the first time we got a link between camp and the Bois Mer Rocher and how exciting that was. I think you and I also kept talking about as because it was such a successful expedition, and we kept talking about how just prepared we were. It was, I think, probably the most prepared we've ever been for an expedition. I think we're also looking forward to talking more about the things we did to prepare for that. And it was, I think, one of the things that made the time go fast was how, just everything just came together. We used the LoRa's LoRa gateways. So this is a LoRa network. I don't know if you'd mentioned that before. And there is a FieldKit LoRa module that I don't believe is on the store, but will be once the app support for it is ready to go. We used Ubiquiti point-to-point 5 gigahertz dishes for the backhaul on that. I'm very proud of it. We brought along some tree climbers, professional tree climbers, to sort of take that responsibility away from us so that we didn't need to worry about that, though Shah and I are trained at climbing trees, so we at least knew what was going on and the choices that were being made. But they did a stellar job. James and Wouter were the gentlemen that we brought along, of getting up in the tree and attaching the hardware and working with us to get it up there. And it wasn't something we had to stress about at all. Got to focus on the technical side of things. It was. And we're excited. I think we're excited about the next phases of that project too.
Yeah, and just to kind of build on what Jacob mentioned, is we did create a LoRaWAN module for FieldKit. So this sits on top of a FieldKit core, and it basically, for those of you that haven't heard of this technology before, LoRaWAN is kind of this low power radio technology that actually has really good range. The only limitation is you can only send small bits of information. So it's essentially text messages is what you're sending through this thing. It's really great for sensor data, right? Because you're just sending a reading, timestamp, and GPS location or whatever it is through this sort of thing. And this is LoRaWAN functionality is something that we do have working on FieldKits right now. And as Jacob said, we're sorting through some of the software side of things to make this technology available to anybody who wants to use it. The exciting thing about it is LoRa gateways are, relatively inexpensive, and there are a lot of them currently out there right now. So if you live in a city and you want to use a FieldKit to measure something, the chances are that you can, for free, use this LoRa gateway to send your information back and get it online. And we just have to sort out sort of what it looks like from a setup perspective to make sure that you have the data that comes through this device connected into the portal as easy as possible.
Yeah, and if you're curious, you can go to the LoRa network we set up participates in what's called the Things Network, which is a community-driven instance of a LoRaWAN network. And so you can go to, if you Google it, you can go to Things Network and see if there's gateways nearby. And chances are, if you live in a populated area, there will be some there nearby you can use and be up and running. There's a lot of DIY maker stuff, a lot of Arduino things that do communications over LoRa. LoRa is also bidirectional, though largely you're going to be receiving data over the network, not necessarily sending a lot of stuff out. But you can use to control valves and switches and that kind of thing. And lots of stuff out there. If you're the maker type, you can probably start tinkering and not have to set up a gateway yourself, because there are quite a few.
Yeah, it's a technology that forms kind of the basis a lot of the smart cities work and smart homes and stuff like that. And so that's why people will put up these gateways that are just free to use for anyone to be able to connect to. So more on that's going to be coming out this year. We'll be sharing a lot of details on how you can incorporate that into FieldKits as well. And if anyone's interested in working in this region, Jacob's holding up a gateway right now. If you're interested in doing any work in the JAW or participating in this system that we set up at this research station, please also feel free to reach out to us. We're happy to connect you with the Congo Basin Institute folks, they'd be happy to facilitate more research in the area. It's a really amazing place, and there needs to be kind of more people trying to understand what's happening in that area. So we're happy to help.
Yeah, one thing that I think is really exciting about the project is how much work y'all already did on the ground around getting the team there, the local team there, trained up in tree climbing and in maintaining the stations and in doing some of the work there, so that it isn't just come in, set it and forget it. There can be that involvement with the local community, and we're currently talking about ways to, get back out there to do more training with, local community members, with Cameroonian-based scientists, so that this is a little bit more integrated and on the ground with the people who, these things impact. And I think that's a bigger piece of a lot of our projects is, we obviously want to be able to get our stuff out there, but more importantly, we want to give folks the tools to be able to do this work and advocate for their own communities and, natural areas.
Yeah, we're, the reason we're open source, kind of the mission behind the work that we're doing is always, how do we give people the tools that they need to answer the questions that they're looking to answer, right? And how can we, it's not something that we necessarily want to always be involved in, because if I can create a tool or something that we can give to someone and they can build on from there and expand and do some amazing work with it, if we could facilitate any sort of that, then we're happy to do so. I think, access to these tools and the ability for scientists in these countries to be able to study these things will just help us much more in the future, helps us understand how this world's changing, helps us stop, parasitic activities like parachute science and move on beyond kind of the situation that that brought us to this point that we sit in today, right? And so if anyone's ever interested in chatting about that or has some ideas around how we can further push that, please reach out. We're happy to talk, and we love hearing new and crazy ideas. We love it.
Yeah, if you heard anything in any of this that you're interested in talking to us about, please reach out. We have a contact form on our website. I'll pop some contact info in the notes to this on YouTube as well. And if there's things that we didn't talk about that you're just like, hey, are you thinking about this thing? Again, we love crazy ideas. We can't always promise that we're going to be able to run with everything, but what we want to do is facilitate a place where those conversations can happen and where we can all build something and build a better world together. That's our whole program for today. I really appreciate if you've watched all this, appreciate you taking the time to get these updates from us. Please don't hesitate to reach out with any questions. We always love to hear from folks, talk about what you're doing, talk about what you're looking to do, and wish everyone a really beautiful, happy Earth Day.
Yeah, happy Earth Day, everybody. Bye.
Thanks. Bye.
Bye.